Hello folks, let's quickly move to the next problem in the miscellaneous. We had done the ninth problem, now we are coming to the 10th one. And the 10th one, it says that the sum of the perimeter of a circle and the square is k, where k is some constant. Prove that the sum of the areas is least when the side of the square is double the radius of the circle. Now this problem is very familiar. It's nothing new to us. Why? Because in the exercise 6.5 we did one problem, like there is a wire which is cut into a circle, and it's cut and then it's converted into a circle and a square. The wire's length is 28 meters, and then find out and so on. The procedure is exactly similar to what we had done there. There they had given the perimeter as 28, but here they call it as k. That's all. So we don't have the number, we have to work with k. So the question is exactly similar to what we had done there. So if we're perfect with the working there, then here it's child's play. So as I told you, just that 28 is replaced by k, that's all. So it's basically you're going to lay emphasis on the perimeter of the circle plus the perimeter of the square is going to be equal to the length of the wire, and from there you're going to eliminate the variables which are coming up. There are two variables, L and R. L is the side of the square and R is the radius of the circle. So from there you eliminate it and you do it. As I told you, if that is pakka with you, then you're able to do it very well. So let's anyhow get over it once again so that we are fresh with what they say. Sum of the perimeter is k. Yeah. So this is our problem number 10, where they say that, let me convert it, sum of the perimeter of the circle and the square is k. So there is a circle and there is a square. For our convenience, we call this side as L and we call this side as R. So let L comma R be the length of the square and radius of the circle. It's given to us directly. In the case in the exercise, they had told us that there is a wire which is bent and all that. It was not directly, we didn't know that it is a perimeter. Unless you think properly, you'll come to know that it's a perimeter. So that wasn't told. But here they are bluntly telling that the sum of the perimeters is k. So that gives you, that makes things much more simpler. So given that the perimeter of the circle plus the perimeter of the square is k. Perimeter of the circle we all know is 2 pi r, and perimeter of the square we all know is 4l equal to k. See, generally in this case we will make a substitution for L. Why? Because we are basically going to look at the area, and when we look at the area, circle's area is going to be pi r squared, so where you will have to square r already. So already pi is there, and this r squared, if it is complicated, it's difficult to work. So it's better we substitute for L. Not that L is going to be simpler, L is also going to be complicated, but sum of their areas, yeah. So therefore, but still a degree better. So let's write 4L equal to k minus 2 pi r, or rather L is k minus 2 pi r over 4. Now why do we do this? We do this because we know that we have to find out the sum of the areas. That is going to be the function that they have asked for, and there we will encounter two variables. One is r and the other one is L. Since we cannot work with two variables, we'll need a substitution, and that's why we are keeping this ready. So let me see what they ask us. Prove that the sum of their areas. So let's write therefore sum of areas. I can call it as A is area of the square plus area of the circle. Now what is the area of the square? It's L squared, we know. What is the area of the circle? Pi r squared. L squared, as I told you, this is going to be our point of encounter where we are going to work with two variables, and then that is derivative is going to be difficult. So we do the substitution. L, let's write this. So it's going to be k minus 2 pi r the whole squared over 4 squared, which is 16, plus pi r squared. Now it will be delicately work with this so that you don't encounter trouble. So let's work with that. A becomes, let's square this, k squared minus 4 pi r k plus 4 pi, sorry, 4 pi squared r squared over 16, and here it is pi r squared. If you want, we can equalize and then pi r squared, yeah. So if you want, whether we should equalize or no, let it be as it is, doesn't make a difference. So let's get the first derivative because we have already got the function in terms of r. So we know we have to maximize or minimize this function. So let's get the first and second derivative. So to get the first derivative, let's take the 1 over 16 outside. K squared is a constant, doesn't have derivative. Let's look at the derivative of this term. It is minus 4 pi k, derivative of r is 1. And look at 4 pi r squared, let it be as it is, and derivative of r squared is 2r. So also here derivative of pi r squared is r squared, derivative is 2r, so 2 pi r. Okay, if you plan to like take the 16 inside, you will get minus pi k over 4, and you will get plus pi 8 twos are 16. That's fantastic. 8 is there, so we will get pi squared r over 2, and this is 2 pi r. Okay, first derivative is done. Let's go for the second derivative. Second derivative, here constant, no derivative. So pi squared over 2, derivative of r is 1, and 2 pi, derivative of r is 1. It's a positive thing. That's why some of the areas is as less as possible, something they are telling is least. So you can get it from there. Now let's switch back to the critical point. Let dA over dr be equal to 0, which means it is maybe this term. So minus pi k over 4 plus pi squared r over 2 plus 2 pi r equal to 0. So let's take this there. So we will get pi squared r over 2 plus 2 pi r equal to pi k over 4. What we can glaringly see is there is a pi common. So let's divide throughout by pi. Then in that case you are left with pi r over 2, pi r over 2 plus 2r is equal to k over 4. Let's equalize this. Times 2 times 2. So it's going to be pi r plus 4r over 2 and k over 4. So you can take the 2 there, so that you will have r common. Pi plus 4 equal to k over 2. Yeah, when this 2 goes there, it cancels. And r basically is going to be k over 2 and 2 times pi over 4. That's your r. And actually that's your critical point. So let's confirm the minimum part. D squared a over dr squared at r equal to k over, doesn't matter at all because there's no r term there. So is positive. So therefore minima occurs. Doesn't matter. Why? Because it's not there, but then that's customary to do it like that. So you've got r. Now they tell us that first of all you have to show that the sum of the areas is least, and side of the square is double the radius. So you have to find out the side of the square, then only you will compare. Side of the square we know, where is it? Yeah. Therefore L is k minus 2 pi. R is there with us. What is the R value? It is k over 2 times pi plus 4. The two can cut each other. And what happens here? Where is our L? Over 4. Okay, I think I'll have to borrow some place here. Yeah. Let's see if we can do the borrowing on this part. We will be moving here. Okay, so what happens? Let's equalize. This has got denominator 1. So let's equalize with pi by 4, pi plus 4. So pi plus 4 minus pi k over pi plus 4. And there is an overall denominator of 4 there. We are moving here. Okay, so let's move here. So that's equal to k pi plus 4k minus pi k over. Now these two denominators, division by a fraction is multiplication by a reciprocal. By that you will get 4 times pi plus 4 when we rearrange it. And these both, they can cancel each other. So we are left with 4k over 4 times pi plus 4. The 4 can cancel each other. So you're getting k over pi plus 4. So k over pi plus 4 is your L value. Therefore R, this is L, okay. So therefore R equal to, see, k over pi plus 4 is L. So it's L over 2. So L will become 2R. That's what they have told you. That show that the side is double the radius. show that the side is double the radius, hence proved. That's it. That's about the proving of the sum of areas. Nothing great because it's already been done there. It's just a replica, in fact a simpler version of what we did there. So that's about it. And with this, with this the problem gets over. As always, please do spread a word about the channel and see that the channel gets popularized. Thank you.